Welcome to this particular course. The course is on electronic systems for cancer diagnosis. Myself Dr. Hardik Pandya. I am professor in the Department of Electronic Systems Engineering at the Indian Institute of Science, Bangalore. And what we will be learning in this particular course is how electronic systems can be designed to diagnose a very important problem, and that is cancer. We will talk about two cancer in detail. One is oral cancer and second one is breast cancer. So, this would be the introduction, and today I will just show it to you what topics we will be concentrating and how it will be useful, so that you can understand whether it aligns with the focus and the learning objectives of yours. So, we will talk about microtechnology, we will talk about how to fabricate sensors, we will see how the conventional class 1000 and non-conventional class 10,000 clean room looks like. We will work on some of the equipment in as a part of the lab component, and if we talk about few objectives, the first objective is to understand the cancer and its properties. As I said, we will be looking at breast cancer and oral cancer. The second objective is to educate on how the process flow for designing an electronic system would be. Now, when we talk about cancer, cancer is very wide subject, and that is why we will be restricting ourselves to tissue based cancer diagnosis. We will talk about that, what exactly happens to the tissue, how can we design a system, so that we can understand whether the tissue is deteriorated compared to the normal sample. The next objective is to develop skills to design electronic systems for cytology based studies. So, what exactly cytology based studies are? The studies based on cells. So, we will talk about how the cell morphology would change, and can we design a system that can look from the morphology angle of the cells. This will be a system that may be used for screening the patient suffering from oral cancer. Our fourth objective would be to develop skills to integrate biochips with electronic system. Now, generally we see lot of courses that in which we learn how to fabricate the sensors, right, but how can we integrate those sensors with a system, so that it becomes a complete system that can be placed in a clinical environment in a primary health center. So, we will be focusing on that particular aspect as well. The next objective would be to take you to the class 1000 conventional clean room and class 10,000 non-conventional clean room. Now, when you talk about clean room, it is used to fabricate microsensors, transducers and microchips, biosensors, microfluidic chips, right. So, I want to teach you how the clean room would look like and what are the equipment within the clean room. So, we will have a kind of a lab training session where I will be teaching you the equipment in detail. And the final objective is to understand how to design again the electronic system with the pre-existing knowledge of basic electronics, and how can we add the additive manufacturing technologies to design the casing of the electronic systems. Alright. So, that electronic or additive manufacturing technologies, we will talk about 3D printing, there can be laser cutting, there can be subtractive technologies also, we will talk about additive manufacturing technologies, right. Having said that, if you see the slide, the first objective or the few of the things that we will be discussing in our course would be to understand the cancer and its properties. We will be designing the electronic systems, then we will see how can we design the entire microscope as you can see over here, right. Then we will see a cancer diagnosis tool for screening cancer. We will be talking about how to integrate biochips with electronic systems. We will see how a clean room looks like, right, and I will give a tour to the actual clean room that I have in my department, and then we will also see how we can design and integrate the electronic systems with rapid prototyping like 3D printing, right. And then I will also show you few of the facilities and equipment and how exactly it is used, starting from autoclave to sonicator to inverted microscope, hot plate, LCR meter, you can also say impedance analyzer, biosafety hood, incubator, oven, vacuum pump, microcentrifuge as well as micro manipulator systems. Lot of things are there. I am only putting few of the things that I want to show it to you today, but there are a lot of things to see and learn. It is not just a theory class, it is a combination of your theory plus experimental laboratory. So, experimental laboratory component is an integral part of this particular course, alright. And if you see the course plan, there are 12 weeks. So, this is a 30 hours course, and we will start with introduction to tissue related cancer. We will look at the morphology changes in the cells, we will look at different microscopes, incubators, that is a basic tissue culture methods. We will see how we can maintain the cells. We will also see how 3D printing can work for packaging. We will also have a hands on experience in designing a 3D printing casing. I will take it to the laboratory, we will execute how to use the 3D printer. Now, we will also see how to design electrothermomechanical systems. We will see how to work in a clean room environment. We will also have try to have hands on experience with bed etching technologies, right. So, overall if you talk about this particular course, it is focused more on how to design electronic system for diagnosing cancer. I hope when you enroll in this course through this NPTEL platform, you will learn a different approach of how to use your prerequisite or basic knowledge of electronics, basic knowledge of 3D printing, additive manufacturing, right, system design, and how to integrate together to solve a particular problem in the clinical domain, right. So, once you enroll, we will talk more about this. Till then, you take care. I will see you when we start the course. Thank you.